Stephen was famous for saying all sorts of things, including the following statement. Asking what happened before the Big Bang is like asking what's south of the South Pole. Now, you know, if you ask what's north of the North Pole, what's north of the North Pole every December 25th? Santa Claus. So he knew enough not to ask that question. That was a sensible question. But he wrestled with the biggest topics imaginable. And those are what we as cosmologists get paid to study. And it's a great privilege to speak about what I do to you here and watching online and all sorts of other venues and environments where I get to share my love of the cosmos. I never thought I'd get paid to do this. I get paid to speak here. Did you guys know that? That Lamborghini outside is needing some new tires, everybody. I get paid, not too much. I also get paid by the regents of the state of California, which is quite excellent. But I always thought it would be impossible. Like, who's going to pay me to taste ice cream? I mean, that would be a great job. No one does that. Who would pay me to ride the roller coaster at SeaWorld? Nobody. Although there is a guy who does that, I found out. But we get to wrestle with these questions. And famously, Stephen, I heard him say this. I only met him once, 1995. He gave one of his final lectures at the Royal Astronomical Society, RAS, in beloved London. I got to see it, and it was back when he couldn't speak for many decades before that, but he had a speech synthesizer, and he could respond more or less in real time, if real time is measured according to how fast you get your income tax refund. I mean, this took hours to get responses. But somebody asked him, I didn't have the nerve back then, I was just a wee graduate student. Someone said, Stephen, why'd you write A Brief History of Time? Tell me the truth. Because it's rumored that less than 1% of the people who buy it have read it. And he took about 5 minutes to reply. He was just typing with his eyes. It was amazing. He had a wheelchair that had a built-in speech synthesizer and visual sightline recognition system. It was built by an engineer. That engineer was the ex-husband of Stephen's later wife. Think about that for a second. This young guy, this sap, he programmed the speech synthesizer, which Stephen Hawking used to woo his wife to divorce him and marry Stephen Hawking. It's an amazing accomplishment with just your eyes. I mean, it's incredible. Anyway, 5 minutes go by at the Royal Society. Finally, the answer comes out in the speech synthetic voice. Stephen said, I wrote the book because I needed to pay for my daughter's college. So at least he was honest. But in this book, how many of you have bought this book? Raise your hand. How many of you have read this book cover to cover? How many of you don't like raising your hand in public? Okay. So about the ratio, 1 to 10 or so of you read versus bought. There is a Japanese word for the art of collecting books with no intention of reading them. It's called santoku, I think. And Stephen was known for having the most number of copies like this. And that's because I think he made a number of whoppers, blunders, boo-boos, oopsies, that nobody would call him on because no one had the courage to contend with this great individual. He really was brilliant, and all the more so, his story was more phenomenal. You know, you couldn't write a better movie. Of course, they did, and that movie came out just a few years before he died. But that was written in concert with his ex-wife, who was the ex-wife of his speech synthesizer programmer. So anything is possible. But I want to refute Stephen thusly. I want to take us on a journey to the South Pole today and ask if it's possible that we could prove, in fact, the question has a sensible answer when you ask it in the following sense. Is it possible that the Big Bang was the beginning of time itself? What Stephen was saying was, since time comes into existence, you can't ask what happens before that thing existed. What did your face look like 400 years ago? That is a nonsensical question. But the question of what the universe looked like before the Big Bang is a perfectly sensible question. People get paid millions of dollars. They get paid to address this question. And we're going to talk about multiple instances of refutations of this claim that it is nonsensical. No, we're going to prove it's very sensible, and we're going to answer it by using technology, hopefully, that I'm going to show you today. And an update from those of you who have not, who have never seen me talk. You're in for a disappointment. No, you're in for a treat, hopefully. But for those of you who have heard it, I have some groupies. I love it. And I will be showing you some recent footage and data from the Simons Observatory. So that's brand new, just this past year. So we're going to take a trip to the South Pole. But first, we want to study cosmology. What is cosmology? Cosmology is essentially the study of everything, if improperly defined, We can actually define it a little bit more precisely by saying that cosmology is the study of the expansion and evolution of the universe. What is the universe made of? Where is the universe going? What existed before our universe? And most terrifyingly, perhaps, what will come at the end of the universe next year? No, it's not going to happen next year. Don't worry. It's going to happen. If it happens, we're actually just recently, just in the matter of past few weeks, there have been announcements that the way that we previously considered the end of the universe to occur, the so-called heat death of the universe, may not occur. We may have an even more exciting fate than an infinitely tenuous, cold, sterile universe. We may actually all rip apart. But keep paying those taxes because it may not happen for 1 trillion years or more. And this will bring up the concept of the multiverse. So I have a couple of homework assignments for you to take up your phones. I never let my students do this up on campus. So now we're off campus, so take out your phone. If you're watching online, you can also take out your phone. I want you guys to subscribe to my special Magic Monday mailing list, which Stephen kindly gave a shout out to. It's free. I give a little tidbit of goodness about what my colleagues and I and other people are doing around the cosmos. It's really fun for me to write it, and exercises a completely different part of my brain than gets a workout in the laboratory or with my students on campus. So you can take a picture of that or just go to my website, briankeating.com/edu. The other thing I'd like you to do for homework, and this is the final homework assignment until the very end, is to subscribe to my YouTube channel. As Stephen mentioned, it has grown enormously. It's the biggest podcast YouTube channel in the University of California. It's bigger than the University of California's YouTube channel. And it's completely self-supported. I don't get any funding from the campus. Pradeep, gives me the only encomium he gives me is good job. He doesn't ever say, here's $10,000 to make your cameras a little bit nicer. So that's fine. And I've had a lot of fun talking with some of the people that inhabit the so-called podcastiverse, which is ever expanding like the universe. And so please do subscribe there. You can go to Dr. Brian Keating on YouTube. You'll find it too. So what this lecture is not going to be, I think, is a joke that Steve wanted to make, but I steal his thunder. He has stolen my thunder in the past, so I get the chance to use my own joke. It's not about cosmetology, but there is a relationship between cosmology and cosmetology. The prefix cosmos. Any Greek speakers here? This room is big enough that we can have some Greek speakers here. Cosmos means beautiful or appearance. Certainly the sky and the universe is beautiful. Mythology, it almost sounds ironically that cosmetology is more technical and grounded in science and reason, but actually it's, of course, cosmology is more of a technical subject, the same way that astrology is not a real subject scientifically. I hate to burst your bubble, but the study of astronomy is. So sometimes when I'm on an airplane and I really feel like I want to talk to somebody and they ask me what I do, I'll say I do astrology. Other times I don't. I say I do astrophysics and astronomy. Nevertheless, they always ask me the same question. I'm a Gemini. What's going to happen next week? Doesn't matter what I answer. So if I tell them I'm a cosmetologist, maybe they'll ask me hair and makeup tips. That would be fine. So where were we going? As I said, we are actually studying the most interesting topic imaginable. We are brains, if you think about it. Brains that can comprehend their own existence. Brains that understand and can think. Brains that evolve from organized atomic living structures, but those structures themselves had to evolve from non-living structures. Entities, organisms that were not alive, pure elements or atoms or molecules. Somehow those evolved into not only living beings like protoplasm or amoebas, but they then evolved to have conscious brains that could contemplate where did they come from. We're the only species we know that knows that. In fact, the name Homo sapien, those of you that don't speak Greek surely speak Latin. Homo sapien means one who knows. Now, what do you know? Sadly, it's many interpretations. One is that we are the only creature that knows they're going to die. We are sapient. We are knowledgeable. We are not wise. That doesn't mean what we think it means. But we are knowledgeable about the fact that our life is temporary. And so, to me, that thought makes me want to appreciate this vast Ouroboros, this circle of life, or cosmic snake that eats its own tail. In order to understand it, we actually get to encounter every branch of science. Some in more detail than others, obviously. If you go to Wikipedia, it shows you the level of seriousness with which cosmology is taken. for a long time, Wikipedia, the source of all scientific knowledge, had as its page, its homepage about science itself, a depiction of what we're going to talk about today. The origin and the evolution of the universe since the Big Bang till the cosmic microwave background, which is what I specialize in, all the way up to the epoch of the generation of the first stars, up into the evolution of galaxies and stars and planets and people and podcasts. We're going to cover all of that. We have only 45 more minutes perhaps, and then we'll have question and answer period, which will be a lot of fun. I always like that the best. But we're really no different than ancient people. Here's a caveman that's like, looking up a Neanderthal or something, and he's wondering, where did all this come from? And then on this other side of the panel by Sidney Harris, famous cartoonist of science, he shows an astronomer asking the exact same questions in front of a huge telescope with some particles surrounding him. It's perhaps the most age-old quest imaginable, that we want to know where it all came from. And in fact, it's the only question that cannot be answered by humans, certainly, but there's even perhaps no record of its occurrence. The Big Bang may have erased itself. It may have originated in such a quantum state, or perhaps in a singularity state, which has an event horizon, which precludes our penetration of that event horizon using our eyes, our senses, our minds. And so it's purely speculative, perhaps. Or it could be that the universe had a state that existed exactly a day before our observable universe came into existence. So that would refute what Stephen Hawking said at the beginning. Remember, that's our goal, to prove him wrong. And he can't really defend himself, so it's kind of cruel. But nevertheless, he got a lot of attention and fame in his lifetime, and he's certainly missed very much. So origin stories fascinate people. I usually do this when I go on with a podcaster who invites me on their show, and I usually ask him or her, what's your favorite day on the calendar? So all of you think on your favorite day of the calendar. Then I'm just going to ask you again, show of hands. How many said it's your birthday, your spouse's birthday? Nobody said that. Nobody likes their own birthday. I don't believe that. Again, how many of you are terrified, have hand-raising a phobia? Okay. How many of you like Christmas or New Year's or something like that? Raise your hand. Those are all beginnings, right? So we're all fascinated with beginnings. We weren't there to witness our own beginning. I mean, we were there, but certainly not the Big Bang that preceded it 9 months earlier. Hopefully, that would be strange. But ever since humans could contemplate and encode their thinking in the written word, humans have struggled with what it all means and where it all came from. So all these faith traditions, from the Torah tradition to the great Egyptian tradition, this depicts a cyclical universe rather than sort of a Big Bang, as some have imagined that the Torah's description, the Old Testament's description in the Bible depicts the universe coming into existence. We have a great tradition that extends forward even more time, closer to the modern era and the Greek era, with people like Democritus and Leucippus. These are all people who thought about things in terms of origins, the composition of the universe. How could you use reason and observation, the primitive scientific method, to unravel and unfurl what did the universe look like before there was anyone or anything possibly there to witness it? Fast forward to Aristotle. Aristotle's a fascinating person, and if you haven't heard a lecture from someone on campus or elsewhere about him, I highly recommend it. He's endlessly kind of inscrutable to me because he was so brilliant about so many different things, philosophy and observations about logic and so forth. But he was such a fool when it came to very simple observations. For example, he believed that women have fewer teeth than men. Now, he could have just asked Mrs. Aristotle, could you open your mouth, or can we go out for dinner on our date night, and can I just have a peek? And he didn't do that apparently, and I don't know why. In other words, observation could have refuted that. He was the first to observe that whales are mammals. That's pretty cool. But besides that, I can't find very many scientific facts that he was correct about. Logic, propositions, poetics, rhetoric, even things like playwriting, the three-act structure, we get that all from Aristotle. So he was brilliant in many ways. But he also thought there were only 4 elements: earth, air, wind, fire, water, fire. He also thought that heavy objects fall faster than lighter ones, which wasn't really refuted for more than 1,000 years until my hero, Galileo Galilei, came along and said, hey, wait a second, what if I just take two things? This laser pointer is lighter than this microphone, you'll take my word for it. And if he couldn't see them falling at the same rate, just tie them together. And now they're one object. So shouldn't it behave weirdly? Shouldn't it fall faster than either one by itself? He never did that. Galileo did that. So he could have done much more observation, and so for that reason, he's not regarded as a scientific methods father. This is an early woodcut around the time that Adobe Photoshop was invented. No, this is about 400 or 500 years old, not really sure. It's called The Atmosphere, and it shows some wanderer, some philosopher perhaps, going beyond what the physical senses could admit to his understanding. So he was able to peer out into the universe in an attempt mentally to understand what came before at earlier times in the cosmos' past. And this is exactly what we're trying to do to this very day. We don't do it with pure paintings, we do it with telescopes. We do it with our minds. It's interesting to note that the telescope came about in part because of the Gutenberg Bible. And then later, the Gutenberg Bible's sort of influence was overthrown during the Age of Enlightenment by the observations done by the telescope and the microscope. So sort of the Bible brought about its own demise in a sense. Because back in the very old days, if you had imperfect vision, you didn't know you had imperfect vision. But when the Gutenberg Bible was first made, the letters were so precise and you could see them or not at a given distance. Your optician, your lens crafters of the day, in Amsterdam it turned out, could make you a pair of spectacles, of glasses. And soon after that, a gentleman named Hans Lippershey realized that you could take the two lenses of your glasses and hold one in front of the other, and it made distant things look bigger. However, for some reason, he never thought to go like this at night. That was left to Galileo. And Galileo cleaned up after that. So there are the spectacle makers in Holland making their way, and then eventually they could use that with the printing press's invention to depict how letters should appear. So you had that vision chart that you go when you go to the eye doctor, always E at the top, and then they have other letters that you can memorize really well if you're trying to get a driver's license desperately. Please don't do that out there, okay? We have enough dangerous motorists here in California as it is. And then Galileo influenced this great man, Isaac Newton, and he came up with laws that then explain the observations in no uncertain terms, but led to a contradiction that he could not resolve, which is that if all matter in the universe attracts all other matter, then the universe is unstable. It is impossible for a static universe to exist. In other words, there was a paradox. The universe sure appears static. In fact, we only have words. We have words for the only 5 things that seem to move on the heavens, besides the sun and the moon. Those are called the planets. Planet, in Greek, my Greek speaker in the back, wake up please, I need your help. No, I'm just kidding. Planet means wanderer. And it's related to, in the heavens, it has an analog in the ocean. Does anyone know what the analog of planet is relative to the Earth's oceans? Any Scripps alums here? Navy personnel in the back? Do you know what's in the ocean? Okay. Got it. In the front row, Ira got it. Plankton. Plankton also means wanderer. What does it do? It wanders throughout the ocean, gets eaten. Planets are the plankton of the sky, except there's only 5 of them rather than trillions of them, that could be seen with the naked eye at the time of Isaac Newton. He actually invented a telescope called the Newtonian reflecting telescope. He was an incredible genius. And there things stood even up into and including Albert Einstein, who also thought we lived in a static universe. And this was very puzzling to him because he knew his laws of relativity implied the universe was also unstable. And so what he did is he inserted a cosmic fudge factor into his equations called the cosmological constant. And it only lasted for about 13 years because 13 years later it was shown by Edwin Hubble that there's no way to avoid the conclusion that we live in an expanding universe, where every galaxy, with the exception of about 5 that are nearest to us and gravitationally bound to us, there's only 5 galaxies out of the 100 billion galaxies we can see with telescopes that are moving. There's only 5 that are moving towards us. The rest are all moving away from us. So it's as if we forgot to put on our cosmic deodorant, or what is it? What's causing that? It's some force, some unseen energy that pervades the universe. And that force may have been there at the very beginning. In fact, it may have been there for all eternity. This theory became known as the primeval atom or the Big Bang theory. And it stated that at extremely early times, the universe was essentially a giant nucleus, which Lemaitre, who was a Belgian Catholic priest, declared to be the primeval atom, this atom from which all the matter in the universe subsequently expanded out from. And if you ran the movie forward, the universe got more tenuous, more sparse, more separated. And therefore, if you remove the movie backwards in time, the universe got more hot, dense, and completely unlike what we witnessed. In fact, at one point, the universe had to have been essentially much, much denser than this primeval atom, and that would be called a singularity. And for decades, that view held as well. And only now are we challenged to find out the question, in this model of the universe, Hawking is right. There's nothing that exists. Time and space do not exist before the Big Bang in this original incarnation of the Big Bang model. But that's not the final word. And it's not because, scientists keep changing their mind. Right now there's a big debate online about expertise. Do you need to study something? Do you need to be an expert in something? Because everyone's entitled to their own opinion. It's true, but everyone's not entitled to their own facts. And what we have to do is study the universe and the evidence it provides to us, which is limited, and do what Galileo told us. He said we should study what's visible and make visible what's not visible. He said that 400 years ago. It's really a statement about what we as scientists have an obligation to do, as we're paid for by taxpayers of, at least in the US, by the US government. So we have an obligation to give back to what we do, and that's why I do things like my YouTube channel, my blog, and stuff like that, because it helps to spread information, counteract disinformation. There are tons of people. There are people all around the globe who believe the Earth is flat. It's very strange. There are many, many more people who even believe the moon landing didn't happen. How many of you saw the moon landing? I was not born. How many of you saw the moon landing? Wow, almost the entire room. It was the event, of the century in many ways. But many people deny it. And many people then say, well, if you can't trust that, we can't trust vaccines. Or if you can't trust vaccines, you can't trust the moon landing. And if you can't trust the Earth is flat. And certainly they can't trust the Big Bang. I mean, it's even more fanciful because we can't fly out into space and witness the Big Bang the way we can the flat Earth being wrong. So since we're here at UC San Diego, I like to show the guys a library. And it rests on these 4 enormous pillars on one side. And so too does the Big Bang theory, not in a sense of, well, that's just your theory, you have this theory that George Steinbrenner will never let the Padres beat them, the Yankees. You can have all these theories, the JFK assassination. How many of you witnessed the JFK assassination or watched it on TV? Many people don't believe that was done by the conventional explanation of a lone gunman. Okay, we're not going to get into that because there's people watching on YouTube. But the point is, there are pillars of evidence. I always say, I don't believe in gravity. I don't believe in gravity. Strange, right? I'm saying it to my 300,000 people on YouTube. No, I don't believe in it. I have evidence for gravity. We've done tests on gravity. We understand its parameters, its force, its fit, and we understand its limitations, its flaws, its foibles, its lacuna. We know what's wrong with it. That's what being a good scientist is. When my students do a lab experiment and they get some value, if they don't show how ignorant they are, even though they're brilliant, they're still ignorant of the truth. No one can know the truth. You cannot prove something scientifically, as I'll demonstrate very, very soon, but you can't prove something the way you can prove 1 + 1 = 2, which also people out there don't believe. There are people out there that believe 1 × 1 = 2, not 1 + 1 = 2. And so it takes up a lot of my time. I don't know if it's really my responsibility to refute every single person's idea, but the point is, even great geniuses get things wrong, but just because you got something wrong doesn't mean you're a great genius. So if you look back into space right now, you see literally billions, hundreds upon hundreds of billions of galaxies, each one presumably populated by hundreds and hundreds of billions of stars, just like our Milky Way. Each one of those with tens, hundreds, or thousands of planets. Some of them very much so could be inhabitable or maybe even inhabited. We have no evidence for that. But again, another conspiracy or another thought process could lead us to believe that there's some great cover-up. How many of you witnessed Roswell? That would be kind of cool. Okay, so no eyewitnesses to Roswell. So the question of how far back can we look is very important. Because if there's a point beyond which we cannot look, we can't gather evidence. Look is just a stand-in for can we apply the scientific method and collect evidence rather than have pure faith, as religious folks are wont to do. And that's fine. This is not a talk about God or religion, but it's a talk about evidence, not belief. So if you look at this guy, who died in 1955, most famous scientist, Times person of the century, last century, and you were to look at him, well, you can't see the galaxies behind him, but if you could, if there was a clean line of sight, you might be able to see back 75 or so years before this image was taken, a few weeks before his death. And let's say you go back to 1878 or so, and you were able to see the same individual, but back then, probably looked like this. Baby Einstein. Used with no permission from the Baby Einstein Corporation. So we can look back as long as there's nothing in our way, so to speak, blocking us. He blocks these galaxies here, but we can presume that if the universe is somehow symmetric and has certain properties that make it easy to predict what its properties are, that even though he's there, we can still infer properties about the region of space behind him based on the region of space that's not obscured by him. Is that clear? Good. So we cover these topics in my lab and in my research. I'm not going to talk about them, other than every time you have a scientific theory, you have to know that it's wrong at some level. The Earth is not a perfect sphere, right? I mean, we're in San Diego, pretty close to sea level. Some people have been to high mountaintops. I'm going to show you a mountaintop at 18,000 feet. Those are minuscule deviations from being perfectly spherical. Actually, the Earth deviates more than that in certain ways at the pole, because when it was formed, it was spinning giant ball of lava, basically, after getting hit by a huge asteroid, a planet-sized asteroid that created our moon. And so it wobbles and it gets bulging at the equator, like some of us do as we get older. We bulge at our equator. But we have plentiful evidence that the universe was hotter, denser, and completely unlike what we see today. That doesn't mean we have to be there to witness it. We can actually witness things about the universe from a simple bottle of water. Steve, the water. Inside of this water are elements and isotopes of elements that could only be made if at some point in the universe's history, fusion was occurring at every point in space and time. That only lasted for 20 minutes, shorter than the TV show, The Big Bang Theory. But that's how we know, based on the relative abundances of things like helium, lithium, and the isotopes of hydrogen called deuterium and tritium. So we know that the universe was a hot fusion reactor from many sources, but it also is a natural endpoint of running the movie that Hubble and Einstein saw backwards. Galaxies are flying apart today. They must have been closer in the past. If you go back to time equals 0, perhaps, they were all together in one point. Not a volume of the size of this room, but every single object, every piece of matter, every form of energy was in the exact same spot. We can't prove that, but we have evidence that suggests that phase was very likely. And now we want to collect more and more evidence following Galileo's dictum that we should make visible what's not already so. So, again, the universe is expanding. We know that because we see objects that have so-called red shift. Their light is shifted towards the red. Just like when an ambulance is moving away from us, we hear a pitch frequency that's lower, longer wavelength. My kids love it when I do this on YouTube. When it's coming towards you, it gets higher, and then it goes away. In the universe, it's like every ambulance is moving away from us, except 6 or 7. The other 100 billion are moving away from us. What's the implication? Something important happened here. But every galaxy can say the exact same thing. You could go to Andromeda, and everyone in Andromeda, all the Osher students there, think they're the center of the universe. So if every point in the universe thinks they're the center of the universe, there is no center of the universe. The universe originated in a point in time, not at a point in space. You can't go to the center of the universe. You cannot go to the origin point of the universe. But it appears like that. And many professors like that. We like to think the universe is centered on us. It began with us, but in fact, it didn't. So Hubble showed this in a telescope in Mount Wilson, not far from here. I urge you to view it. And we also have evidence, as I said, from bottles of water, even as simple as that, or the ocean, or other galaxies and stars that we can see, that the composition of the early universe was this primordial soup. We have abundant evidence for that. We don't have to have belief in that. We have evidence, but we'll never have proof. Science is frustrating. Math is easy. There's a proof called Gödel's incompleteness theorem that suggests there are certain things about math that can never be proven. So you sort of know what's mathematical, what's not mathematical. There's no such thing in science. There's no such thing that says, actually, you're studying astrology, and therefore, by this law, mathematically provable, you're studying something non-scientific. You can make arguments, appeals to logic, and authority, and plurality, and other things. But you can't actually prove it mathematically. So it's frustrating, but it's fun. It's very fun to do as well. So we have this view of the world and the universe, looking out from, in this case, the bottom of the world, which is the top of the world, to the penguins that live there, seeing planets, stars, galaxies, the CMB radiation that we'll talk about. And then eventually, there's a dark age. We don't know what happened. That could be because the universe came into existence and is shielded by our vision by an event horizon every bit as impenetrable as a black hole's. Don't believe what Kip Thorne and Matthew McConaughey conjured up in Interstellar. You're not actually able to transit into and out of black holes. But nevertheless, we can ask questions and go as far back in time as possible. It's kind of like, what's your earliest memory? One of my kids claims he can remember something from when he was age 2. I said, prove it. He said, my dad was really nice. No, he's... I don't know what my earliest memory is. I think it was 4 or 5. I can't really date it. But if you could go back further, and in fact, if you could go back and someone told you, hey, I found a book. It was written by your great-great-great-grandfather. Would you want to buy that book? Would that be interesting? Well, I've got it on sale. It's only $10. You'll get it after this. No, it's not written by your great-grandfather. It's written by me. I will be selling them after the talk. So is this all settled science? I made a kind of persuasive case. At least I like to think so. But actually, no. No science is settled. Science is never settled, and that's why it's frustrating. There are plenty of people, including my late great colleague, Jeff Burbidge. I have his old office at UCSD. He believed the universe till his dying day was a steady state universe, that the universe never had a Big Bang. He used to verbally assail people who would come and speak about the Big Bang. And he had this huge, larger-than-life presence. And it was very intimidating, especially to a new assistant professor. And his wife, Margaret, was the exact opposite. Reserved, dignified, very, very not given to the using many words. And she was one of the foremost astronomers in history. She started effectively what became our astronomy department. Just recently actually codified as an astronomy department. But there are many, many people who rejected the Big Bang, Fred Hoyle among them, and certainly Jeff Burbidge and others, and certainly the late, great Nobel laureate Steven Weinberg, who said that people don't like the Big Bang because it resembles Genesis 1:1. It seems like, let there be light. The universe came into existence. Nothing else existed before it. God said, let there be light, the motto of the University of California. So it seems like, well, if you're against the Big Bang, maybe you have some ulterior motives that you might also be against religion. And 93% of my colleagues are either atheists or self-declared agnostics, and therefore they don't actively affirm a belief in God. And so some of them have some, maybe psychological, I'm not saying they're wrong, but they might have some extra scientific, non-scientific reasons for rejecting the Big Bang, as Steven Weinberg himself had enough integrity to admit. Or as I like to say to my British friends, anyone speak English here? British English, we're divided by a common language, right? Banger, if you didn't have a Big Bang, you don't need a Big Banger. So the stakes could not be higher. I'll skip over this. We witness the thermal afterglow of the Big Bang. It's another form of artifact, just like the water molecules I said in here, that come from only nuclear processes that cannot happen at a reservoir here today. It can only happen if the entire universe was a nuclear fusion reactor. So too, there are relics in the form of neutrons, protons, neutrons and protons in the water, and their assemblies thereof. We're only made of basically 3 different things that are in this room, only. Up quarks, down quarks, and electrons. There's photons and neutrinos in here, but we're not made up of them. So it's a very simple ingredients list. You get the incredible abundance from a flower to the smile of your spouse. It's incredible. Those are all relics. They all exist only because of these 3 things that existed at the Big Bang's beginning, or possibly in a universe that existed before the Big Bang, as I'm about to explain. So again, remember the stakes. Stephen Hawking was a famous atheist. He used to say things like, "Thank God I'm an atheist." No, he never said that. But he did say that he put things about God into his books to sell more copies. And actually, the end of A Brief History of Time, which only you have read, but many of you have bought. I actually hope for the same for my books after this lecture's over, that many of you will buy it. No, I hope you all read it and buy it. But he said, if we can come up with a theory of everything that unifies all the forces of nature together, understand inflation, understand string theory, then we will know the mind of God. So he was no fool about, again, selling books, paying for his daughter's college tuition. He knew that appealed to people. He said it in his memoirs. But he didn't believe in it. And so the question is, can we refute this? Are there alternatives? Again, the Earth isn't a perfect sphere, but it's sure more spherical than it is flat. So we have evidence for it not being flat. We have imprecise evidence that it is very close to spherical, but it's not. So I codify this to my students by saying flaws lead to new laws. Once you see something has a flaw, like the steady state theory that said the universe was around forever, Einstein had to reject that based on the new data of Hubble. When the new data came in, he used them and said the universe could have had a beginning. So the flaw in the original model of a static universe led to the new law when there was new observational evidence. That's our job as scientists. Nowadays, there are multiple alternatives to the Big Bang. The Big Bang being the origin of time as Hawking conceived of it. Again, Hawking, one of the most eminent scientists of our time. They claim he's not only wrong, but completely factually incorrect. And the only way, though, as a scientist, we can refute one or the other. Remember, we can't prove one or the other is true. I can't prove that the Big Bang happened. I can't prove that an alternative happened. I can refute that things happened. And that leads us to step by step closer to the truth, just as ruling out the flat Earth led to the realization, that the universe, that the Earth, is made up of this spinning object, which led us to more and more information. Geology, tectonic plates, the tides, all these things are related. So when you reject a model that's wrong, often you learn more about things that you never would have predicted had you just kept that wrong model going time after time. And we're trying to do that, in a sense, with the singular origin of the Big Bang. There are a bunch of different models here, but what I want to show is one of them in particular, made by an eminent friend of mine who's the Einstein professor at Princeton, not to appeal too much to authority, but he has this model where the universe exists because a previous universe effectively sacrificed itself and was resurrected after a big crunch to cause a Big Bang, and the event happened with very, very little energy compared to the singularity that Hawking and others assumed our Big Bang started with. So there's no singularity where this point vanishes into a complete and utter quantum singularity. As Hawking declared it, that type of singularity is where God is dividing by zero. You're putting some finite amount of stuff, matter, energy, into an infinitesimal or zero volume. So you're dividing something finite so it has infinite density. There's no evidence for anything in the universe that's infinite. As Einstein said, there are only 2 things that may be infinite: the universe and human stupidity. And I'm not too sure about the universe, he said. So there is a model which leads to the so-called multiverse. It's called eternal inflation. And one of its fathers, Andre Linde, I've had the privilege of talking to on my podcast, along with many other people, 21 Nobel laureates to date, and growing. So I hope you all will subscribe to the podcast, listen to it. I try to keep it accessible to a layperson, but also get into some of the nitty-gritty conversations that scientists have to get degrees and degrees closer to the truth about our universe. So inflation suggests effectively the universe of Stephen Hawking. There was a Big Bang, a singularity, something very close to a singularity, from which all the matter and energy occurs in the universe. But not all the energy, that's not all. There's also an infinite amount of energy to produce an infinite number of universes. When we were kids, the universe was everything there was. Now, cosmologists, many of them suggest, including people like Hawking, in his books and in his papers, that we're actually not only in a universe, we're in a pocket of the multiverse. What we call our universe is just a tiny little corner of a much vaster landscape, many, many trillions, billions, maybe infinitely bigger than our observable universe. It's fantastic, and it's amazing to think about. The question is, can we prove it? No. Can we falsify it? Perhaps, perhaps not. Are there other models that we can rule out, getting us closer to truth? The answer is yes. There are many pieces of evidence, there are many historical instances of where people believed in multiverse-like things. There are other planets, we know. There are other stars, galaxies, clusters of galaxies. Why not let there be clusters of universes? It's effectively extending the Copernican principle from the mere planetary perspective to the multiverse perspective, not even the cosmic perspective, as my friend Neil deGrasse Tyson says. And today I was on his podcast. Well, the episode came out where me on his podcast, my second appearance on his podcast. So look for that. I will also put it on my YouTube channel and my newsletter. So could there be? Sure, there could be. Do we have evidence for it? Well, let's look. There are eminent scientists, including the creator of the theory of inflation himself, Professor Alan Guth of MIT, who came up with the theory of inflation. He's about to get fired from his job as a postdoc at Stanford, a feeling I know all too well. And he actually came up with this incredible theory that explained not only how the universe might have come into existence, but why it's expanding, why it has the properties that we observe it to have to this very day. It was very powerful and remains the most credible theory of the extreme early universe. But that doesn't make it right. One of the consequences is that it's unavoidable, according to him, father of inflation, and the father of what's called eternal inflation, which means that inflation occurs, Big Bangs occur in every part of the multiverse simultaneously, that you must have a multiverse. So this is really saying something profound. That we live in a universe because we live in a multiverse. Does that make sense? We only exist like bacteria in a petri dish. The petri dish is the only reason the individual bacteria can exist. If the individual bacterium looks to his neighbor and says, oh, there's another bacteria there, then they could both surmise, if they had brains and consciousness, they were bacteria, E. coli sapiens or whatever, they would know that not only are they going to die, presumably when some bleach is applied to them, but they're also part of a much vaster landscape than they can see observationally around them. There are other instantiations of the multiverse, the most famous of which comes from quantum mechanics, which suggests that at every moment in time, instead of the so-called collapse of the wave function, which is the most popular interpretation that physicists have used since the 1930s, Niels Bohr and others, that the universe evolves such that no wave functions ever need to collapse. That Schrodinger's famous cat is alive in one universe but dead in the other universe. Poor cat, poor Schrodinger's cat. That actually the multiverse of quantum mechanics, called the Everettian many worlds hypothesis, I have many interviews on my channel about that if you want to go deeper, that at each time there's an observation made, each time in your life where you made a choice, it was sort of, choice could be allowed, but all alternatives occurred. You asked your wife out, she said yes, she said no. Okay, for some that's a blessing. No, I don't give out any marital advice. I just say that it's hard to find a perfect man because my wife got the last one. So this comes from many different avenues. Just as evidence for the Big Bang comes from many different avenues. It comes from the cosmic microwave background. It comes from the expansion of galaxies. It comes from the abundance of elements in water that you can test yourself and proved could only exist because of a fusion-like reaction in the early universe. We have also abundant pieces of evidence for the multiverse as well, or at least examples of how it's possible. Not that it exists or is definite, but that which is not forbidden is compulsory. It has to happen somewhere in the universe. That's the argument. So the stakes could not be higher, like cows on a high mountaintop. That's one of my kids' jokes. That's not even a dad joke. That's a kid joke. Cows on a mountain, the stakes could not be higher. Come on, people, wake up. There's a coffee shop right downstairs. There are many different models that don't have a singularity. Their main virtue is that we can prove them wrong, not prove them right. In science, we cannot prove things, as the great philosopher Karl Popper said. He was one of the most eminent logicians of all time. He said, you can't prove something in science because things that are pseudoscientific are so flexible they'll admit any explanation. Like when the person on the aisle seat asked me sitting in the middle seat what their horoscope's going to be. I can't say, oh, it's actually total nonsense. She'll say, well, I went to an astrologer once and he told me blah, blah, blah. Because they'll usually say stuff like, the stock market will fluctuate. There will be turmoil in the Middle East. They're so admissible to any alternative, they prove nothing. Nothing at all. So he said, look for things you can prove wrong. You can prove wrong. Falsifiability. And so that's what we do as scientists. We don't prove things right, we exterminate things that are wrong. It's an awesome power. And the way that we do it is using, in this case, we can falsify the alternatives to Hawking's universe. We can falsify them if we observe this pattern of polarization called B-mode polarization, which I've talked about before, and I've done many videos about, and I will continue to do so because it's how the bread gets buttered around the Keating household. The CMB has this particular type of polarization. Polarization I actually explained to Neil deGrasse Tyson in the podcast that I did with him on his channel, and so you can learn more what is polarization. But suffice it to say, an orientation of light that can only occur if the Big Bang produced this inflationary epoch. So it's really an inflation detector, which means it rules out the other types of universes if we see it. It doesn't prove inflation, but it rules out the things that say that cannot happen. Okay, is that clear? It's not a proof. It's a refutation of alternatives. Just like we falsified and refuted the flat Earth. We can't prove the spherical Earth. It's not spherical. And to specify the height at every point in space and time for all time is impossible too. What's the height of the ocean right now? I don't know. It varies. So you can get closer to the truth through an approximation method, but you can falsify large classes of things. You can say the Earth is not a Pringle chip. It's not a hyperbolic toroid, as other shapes that we could rule out as well. And that's the power of science. But it's uncomfortable because you'd like to be able to prove stuff. So we built this telescope. We took it to the place where Hawking said you could not go south of, which is the South Pole. And we put it there. It's the very bottom of the world. There it is right there. South Pole, Antarctica. It's a very dangerous place. You go there, and you're at the place where these men all died. These were the second team of people, led by Robert Falcon Scott, who arrived at the South Pole in 1912, 3 weeks after their arch nemesis, Roald Amundsen, had arrived there. It would be like Neil Armstrong stepping off of the Eagle onto a Soviet flag. It was the most crushing defeat in human history. Even worse than the Padres last night against the Yankees. I'm not bitter. I used to be a Yankees fan. I'm not bitter. But when they saw this site, they saw a Norwegian flag. They had got there 3 weeks too late because they were trying to do science on the way. They kind of played a little too much in terms of scientific games, and they paid with their life. They all died. This selfie was one of the last pictures they ever took. They died a few weeks later, frozen to death, horrible way to die. But they had been the second people to reach the South Pole. And today it's still an incredibly violent and dangerous place, as well as this image of me there last time shows, with people think these penguins are so cute and cuddly. One of my kids loves them, wants me to bring one back. I understand it. I mean, when you go to a restaurant and you can't decide between the chicken or the fish, I'm told penguin. No, you can't do that. You can't go there. But you go there, there's actually a pole, and there's a huge building paid with your tax dollars. Thank you very much. Hopefully it'll be continued to be paid for by your tax dollars, although right now that's up in the air, literally. This is on 9,000 feet of ice that's accumulated over 65 million years. And it's a continent. The South Pole is on top of the Antarctic ice sheet, which rests on top of Antarctica, the continent itself. This is the telescope that I designed originally as a postdoc before I got fired from Stanford. That's the topic for my book, another Osher talk. And it's the second most important building after the outhouse at the South Pole. We detected this pattern. Remember I said the swirling pattern could not prove inflation took place, prove the singularity, and prove the non-existence of anything before time equals 0 of Hawking if we saw the swirling, twisting pattern of polarization. That is what we saw. This is a mock-up of it. And we saw this pattern, and we were on the front page of the newspaper of record, yes, the San Diego Union-Tribune. I'm a subscriber. And down here, we have a subscriber from The Economist. They advertise on the Into the Impossible podcast. I like this headline because it kind of sounds like there's some guy, and he's just watching. Oh, wow, I saw the beginning of the universe. But again, it's seeing the start of the universe. Is that strictly true? No. It ruled out the existence of a steady state universe, of a static universe, of a bouncing universe, but it did not prove beyond a reasonable doubt or shadow of a doubt that the universe began with time beginning at 0, nothing before that time. It doesn't show that at all, so it's not a start. So The Economist, sorry, I hope they keep advertising with me, but you were wrong. It was on CNN. But unfortunately, since my first book is called Losing the Nobel Prize, you might guess that we actually did not see the actual Big Bang's beginning. Instead, what we saw was this magnetized particles of dust, basically micrometeorites, which I will give to each one of you who buys a copy of my book after the talk today. I brought a bunch of copies. And this is highly magnetic. It sticks to this magnet right here. And you can play around with it, give it to your kids, grandkids, however you like. But microscopic versions of this pollute the cosmos and mimic the signal that we sought. And so we, unfortunately, lost the Nobel Prize, as I described in the book. But it launched a new revolution for us, which is to do what BICEP 2 could not, which is to observe the universe in multiple wavelengths, with multiple detectors and multiple telescopes. BICEP was a single telescope with a single frequency with a single type of detector. To get rid of the dust and to see these patterns called B-mode polarization, you need a vast array, more telescopes with different power and a great deal more of them. So this is our last meeting. It was started in the seeds of it came about because of the BICEP incident. Jim Simons, a family friend, he has donated, he's passed away now. Actually, I think today is his anniversary of his death, first anniversary of his death, May 7th. And he had donated, his foundation has donated $80 million to the construction of this observatory, which bears his name. Now, it's not a super sucker, like sucking up the dust and the micrometeorites. Instead, it's an array of telescopes, and I want to show you it. It's located in Chile. It's not located at the South Pole for technical reasons I describe in my book. And we've actually come upon making actual data. We've had observations of astrophysical objects and even of the cosmic microwave background. And we're on a path to either showing how much gravitational waves there were in the universe or setting a limit that essentially rules out most of the opportunity for there to have been a singular Big Bang of the kind that inflation predicts. We were featured again in the newspaper of record in the New York Times this time. On the front page of their Science Times. I can send you guys a link to it. This is a drone view of it. I have an actual drone video of it somewhere in here, taken by our social media folks. So this is actually what it looks like. If you're there at 17,000 feet, you're above half the oxygen, half the atmospheric pressure that we feel here at sea level. You have to wear oxygen masks, hard hats, boots, jackets. It's freezing cold. There's UV rays. It's an incredibly intolerant place to be, but it's also very beautiful. Stark, it looks like the surface of Mars. In fact, they do some Mars testing there. There are other observatories up there. It's a nerd's paradise. I love going there. That's a telescope that's over almost 30 times bigger than the BICEP telescope. It has incredible capabilities. That one's named after Jim Simons. And those pointy little things in the background, oh, those are some dormant volcanoes, not inactive volcanoes. They're actually, sometimes will spew out lava and fumes. And we'll get in our weather report, there's a 30% chance of volcanic fallout today. Nice way to start your day, especially when you come from San Diego. We have enormous instruments. This is built by my friend Mark Devlin and his team at UPenn, operating now. That's the size of one of the telescopes we built here at UCSD in the lab. installed it in the site and been taking data for over a year with it. These are the detectors made by my brilliant colleague, Suzanne Staggs at Princeton. She's made almost 100,000 of these, or she will by the end of the project. We're going to observe for the next 4 years, and then by the end of that 4 years, we should be able to start checking off boxes on this scorecard. The inflationary report card should have some boxes ticked on it. Because we may reach a level beyond which we would expect to see signals of inflation in the most plausible models. Or we could see something that is completely different from what we expect. And that sometimes is even more exciting than setting out and finding what you sought out to look for. Again, the multiverse is contingent upon inflation occurring. Inflation is equivalent to Hawking's idea of time equals 0 and no time before the Big Bang. Of course, the elephant in the room, or the mastodon in the room, as my friend Paul Davies once said, if the multiverse is true, it's kind of just taking up some pseudo-scientific language and saying that anything can happen because there's an infinite number of possibilities. So we find ourselves in a particular pocket of the multiverse because it has the conditions that are suitable for us to be found in that pocket of the universe. To him and many others, inflation is bad science because it's so flexible that anything can happen and therefore it can't be refuted. So again, things could not be more urgent for astronomers and cosmologists at least. Oops. So I want to leave you with this picture, which shows 3 different types of dust. It shows this rocky landscape in Arizona. A friend of mine took this picture. It shows the Milky Way galaxy, which is filthy and polluted, not unlike Los Angeles. And then in our blood, in these 2 creatures in the foreground, Homo sapien sapien, people that know, that are wise, that know they're going to die, flows blood within which is containing hemoglobin, at the center of which is iron, which is identical to the iron in this meteorite. And you will prove that to yourself when I show you the chemical and X-ray spectroscopy that we've done on it when you get your copy of my book after the talk. So I'll leave you with that.